Good morning. Today we're going to talk about our very first really true calculus thing, and I am so excited about it. We're going to talk about limits today. So when you think about a limit in everyday terms, you can think about things like speed limits or weight limit, a limit on the number of items you can purchase with a coupon. It's a bound. It's something that in theory you're not supposed to go over, for example, for your speed limits. So the limit notation that we're going to see in our problems is shown here in your box. We would read this as the limit of f of x as x approaches c is L. So our limit is going to be whatever number is here. We're going to have a function, and then we're going to always see this notation, which is telling us as x goes or gets closer to whatever this c value is. Okay, so we're going to break limits down into a couple of days, and we're going to start first by just looking at tables and graphs. So that's what we're going to focus on in this video. So finding limits graphically, I've got a lot of information here for you. Here's what a typical problem might look like. We're wanting to find the limit as x approaches 1 of the function x squared plus 1. So I've already got it graphed for you over here, and you can graph it in your calculator to confirm that's what it looks like. If we look at the values in the table, okay. Oh, I forgot one thing. Let's write down these questions too. I got ahead of myself. I was too excited. So one thing we're going to ask ourselves is, what's happening as we get closer to whatever that x equals c value is? So what's happening as we get closer to x equals c? Another way you can think about that is, what's the intended height of the function? Okay, so what's happening as we get closer to x equals c, and what's the intended height of the function? So we're going to look at this in a couple of different ways. So if we look at the table, you have your x values across the top here, and then f of x is your y, so this is like your answer, what you would get if you put 0.9 into this function and typed it into the calculator. All right, so at 0.9 we have 1.81. Notice we get next 0.99, so we're getting values that are closer and closer to positive 1. And we have the same thing happening here. As we get 1.1, we get a little bit closer. We do 1.01, 1.001. Okay, so we're talking about as x approaches 1, we're looking at it from the left and from the right. Okay, if you look at these values for your outputs, as you go to the right and as you go back to the left, you're going to notice that those values get closer and closer to a value of 2. So our limit for this function is going to be 2. How do we see that on the graph? If I look at my x-axis, right, as I get closer and closer to 1 here, we have to look up at what the y is doing, the output. My output is getting closer and closer to a height of 2. So the intended height for this function would be 2. So I'm going to go ahead and write 2 up there for the limit. Now notice the value of the function, f of 1, is also 2. We're going to talk about that might be the case, but that doesn't, the value doesn't determine what the limit is. Okay, so I'm just going to make a note here. The limit is not the value of the function at x equals 1 in this case. Okay, they can be the same answer, they can be the same number, but just because I know the value is 2 does not mean that my limit has to be 2. Okay, so I don't want you to oversimplify what we just looked at there. Okay, so let's go on to the second example. We're doing a lot of looking here, not a whole lot of writing. For number 2, now our function is the limit as x approaches 1 of x squared minus 1 over x minus 1. Again, I've given you a table and I've given you the function, the picture of the graph. So notice here that in our table, we've got the same values because we're still approaching 1, a little bit different outputs because the function is different. Why is there a question mark here? There's a question mark here because if I try to substitute 1 into my function, you're going to end up with 1 minus 1, and you'll have a 0 in the denominator, okay? So the value of the function at f of 1 is undefined. Or like if you were to type it in your calculator and look at the table, it would say error, okay? So that's undefined. But we can still find a limit. As I look closer and closer and closer to 1, as my x gets closer and closer to 1, my y's, my outputs, are getting closer and closer and closer to a value of 2. Okay, let's see if the graph gives a similar answer. As we get closer and closer and closer to 1, okay, and if you need to, you can think about, like, get some paper on there. As you get closer and closer and closer to that x value of 1, all right, so your eyes are right here, you're looking closer and closer and closer, you're approaching this like open circle, which is at a height of 2. All right, we have the open circle there because the function is undefined at 1, but I can still tell what my intended height is. The intended height of that function is going to be 2. So the limit as x approaches 1 of x squared minus 1 over x minus 1 is going to be 2. Okay, so the thing that I want to note here, and let's mark here that this is a hole. Okay, we got room down here. Okay, it doesn't matter that f of x is undefined at x equals 1. We can still find the limit. All right, let's look at a couple more examples. Number 3. All right, so here you have the limit as x approaches 1. We're just keeping it simple. We're not changing too many things on you yet. Here we have the absolute value of x minus 1 over x minus 1. Okay, so if we look at the table, again, our x values are getting closer and closer to that positive 1 from both directions. If you look at the left-hand side here, our values are always coming out to be negative 1. So it would seem like they're approaching negative 1, right? It's not like they're getting close to 0 or anything. If I look at the right-hand side, these are approaching, staying constant, really, at a height of 1. So what you're going to want to do here, which is not correct, is you're going to want to take the average. Don't take the average. We should make a note. Not finding an average. Okay, so 0 is not the answer to this one. Okay, let's look at the graph and see what's happening here. So same function. As I look at the function from the right, okay, as we're getting closer and closer and closer to 1, my height is staying at that positive 1. Okay, as we get closer and closer and closer from the left, my height is staying at that negative 1. So what does this mean? Mean girl people out there? This means that the function does not exist. Okay, if you haven't seen Mean Girls, you didn't get that reference. I wasn't calling anyone mean. If you want to abbreviate that, you can put D and E. Does not exist. Okay, the reason it does not exist is because it, meaning the function, approaches 2 different heights as we get closer and closer to x equals 1. okay? So now we've learned a little bit more about limits. It's going to be your intended height. You're going to look at it from the left and the right, and it has to be going to the same number. We're not just taking an average of the intended heights from the left and from the right, okay? If it's not approaching the same height, then then the limit will not exist. It's going to be does not exist, okay? All right, number 4. Here we have, if you don't remember what this is called, this is a piecewise function. Put that up here. Okay, so piecewise function, we have really 2 functions here. The first function is going to be y equals x, as long as x does not equal 1. And the second function is going to be y equals 0 if x equals 1. Okay? If we look at the table here, as x gets closer and closer and closer to 1, this looks like it's getting closer and closer and closer to 1. And if I check it from the right-hand side, as we get closer to 1, this is also getting closer to 1. Okay? Notice my value, this is f of 1 equals 0. My value is 0. But my limit looks like it's approaching a different number. It has a different intended height. On your graph, and this probably didn't copy very well, so make sure that you see this, there's supposed to be a filled in circle at the point 1, 0 that represents that value, okay? So as we're looking and getting closer and closer to 1 from the left and the right, again, we see that the line is getting closer and closer to a height of 1, okay? So my limit for this function is in fact going to be 1. Okay, so again, we'll note that the value and the limit can be the same number, but the value does not determine the limit. Okay. All right, so all of this is summarized, and I went ahead and typed it out just so you wouldn't have to write all of that stuff down into these 3 important ideas, okay? So the value of f of x may be arbitrarily close to the limit by choosing x closer and closer to c. That arbitrarily just means you can pick any number. You just want to make sure it's a number that's close. So like in our tables, we were choosing 0.9 and then 0.99 and 0.999, okay? So we see that in example 1 and example 2, right? The second idea, for a limit to exist, x must approach c from both sides of c. If it approaches 2 different numbers, then the limit does not exist. And we saw that in example 3. And then the third big idea, the value of f of x when x equals c has no bearing on the existence or non-existence, or the answer, of the limit as f of x as x approaches c. And this was example 4. Okay. And there's just kind of in summary your definition of a limit that kind of summarizes all 3 of those ideas and tells you again how to read that notation. Okay. All right, we are going to keep going, and now we're going to actually create the table and the graph ourselves. All right, so flip over to the next page. Pause if you have a question, if any of that's confusing. But really all we've done there is just read the graphs that are given to us. We haven't actually, created a table yet, so that's what we're going to do. Okay. Because when we look at limits, we have to make sure that the function is approaching the same height from the left and the right. We have these things called one-sided limits. So your left-hand limit in your notation, you're going to see, x approaches some number, and then you're going to have a little negative sign, like where you would see an exponent. So that just means that you're approaching from the left. And if you have a right-hand limit, then you're going to have x approaches c, and you'll have a plus sign in the exponent. So just think of that like you would a typical number line to help you remember that. Here's 0. On the number line, you have positive values on the right, so that is going to be a right-hand limit. And you have negative values on the left, so you have a left-hand limit. You're approaching from the left, okay? So again, for the limit of a function to exist as x approaches c, it must be true that both one-sided limits exist and are equal, okay? All right, so make sure you have a calculator for this because we're going to fill in some tables here. You are going to, now when you type this in the calculator, you don't do anything with the limit as x approaches 4. You are just working with the function f of x equals x plus 1, and you are going to substitute in each one of these x values that I've given you. You know, if you need to, type it in the calculator, and then you're going to fill in your table below. Okay, so go ahead and pause the video and do that, and I'm going to go ahead and write them down. Okay, so if we look at the limit as x approaches 4 from the left, and I'm writing it on the left there, we want to look as we get closer and closer and closer to 4 in the x, what are my y's doing? My y's are getting closer and closer and closer to a height of 5. Okay, so my left-hand limit, if I was asked to find the left-hand limit, I would say 5. Okay. If I want to find the limit as x approaches 4 from the right, we have 5.01, 5.001. It keeps getting even closer. So my right-hand limit of this function would also be 5. All right? Because both of these left and right-hand limits are giving me the same value, 5, the limit of the function as x approaches 4 is going to be 5. So 5 is our answer there. Okay, go ahead, pause the video, and let's have you do, I want you to look again, I want you to look at the limit as x approaches 3 from the left. Do the limit as x approaches 3 from the right. Okay, do that after you fill in your table, and then see if you can decide overall what the limit is going to be as x approaches 3. Okay. Pause your video and give that one a try. Okay, now for number 3, we are going to have to draw a picture for this. Or I want to draw a picture to make sure you understand how we do the graphs for these piecewise functions, because if you've done it, it's been a while. Okay, so the first thing we're going to do is we can kind of make a table, and I'm going to write this out. Not that you need to show all of this work all of the time, but just to make sure it's clear on where things are coming from. Okay, and I'm gonna get my my graph started over here. Okay, so the first thing we're gonna do is we're gonna evaluate just the top function. And we have to evaluate it. It tells us for x values greater than or equal to 0. So I'm going to start my table at 0, and we'll put in, you know, a couple numbers. If I substitute 0 into this function, I'm going to get 0 out. If I substitute 1 in, we're going to have 1, 2, 3. Okay, so on our graph, we're going to have points at 0, 0, 1, 1, 2, 2, 3, 3, and it's going to keep going up from there. All right. For your second function, your bottom function, for f of x equals 2 minus x, we're going to do the same thing. And it seems like you shouldn't put 0 in, but you're going to put 0 in even though it says that x should be less than 0. I just know that because I can't put this in, whatever answer I get out here, I'm going to show that as a hole in the graph, or an open circle. I don't want to run into my graph there. open circle. So if I substitute 0 into my function, 2 minus 0 is going to give me 2. So at 0, 2, we're going to have an open circle there. Okay, and then we can do less than 0. So negative 1, negative 2, negative 3. 2 minus negative 1 is going to be 3. And then we'll get 4 and 5. So negative 1, 2, 3. Negative 2, 4. And negative 3, 5. Somewhere in there. They're both lines, so you just have two different rays going off your graph. Okay, so the reason I put 0 in there is because that's the easiest way to figure out what's happening between 0 and the first whole number that I can substitute in, negative 1. So the easiest way is to just put your 0 in there at whatever your cutoff is, and just know that that's going to have to be an open circle. Okay, so now we want to find the limit of f of x as x approaches 0 from the left and from the right. Okay, so for the left-hand side of the graph, you can basically ignore this part. Okay, as we come at the graph at 0 from the left, my line is getting closer and closer and closer to an intended height of 2. Okay, so the limit as x approaches 0 from the left has a height of 2. If I look at the right-hand limit, cover up that part, as I get closer and closer and closer to 0, my height is getting closer and closer and closer to 0. So the limit as x approaches 0 from the right is going to be 0. So I can find a left-hand limit and I can have a right-hand limit, but if I'm asked to find the limit overall for this, and I'm just going to go ahead and do this here, the limit as x approaches 0, because I'm coming to two different heights, I would have to say that the overall limit does not exist. Okay. All right, so on the back of your paper, it tells you to draw the graph of the piecewise function, but I already gave it to you. So use this graph, see if you can find the left and the right-hand limits as well as the overall limit, and I want to check those answers. And then you're going to do number 5, so the graph is there for you, and you're going to try and find the value of those limits, okay? If a couple of you have gotten done with the video and you're working on that together, that's fine. Just let me know when you are ready for me to check. And your homework problems for this section are going to be on page 60. At least that's where it starts. You're going to be able to do 1 through 12 and then 15 through 20. Okay?